Grace, was it Grace 2 years ago?
Probably.
Yeah, she invited me to come down and talk about the graphics and the highlight, and she had, think about how I want to say that, I had made comments in class with students joking around, hey, I saw your graphic, and, well, I don't know if I like that one, and so she's like, hey, why don't you come down and talk to us? So I'm like, yeah, that'd be fun to do. So I took what PowerPoint I did 2 years ago and just thought I would just keep the same one. I started to change it and then fell asleep last night. So I woke up this morning and remembered, uh-oh. So, but a lot of good stuff is in there. So I just want to talk about, when we're making graphics, what should we be thinking of and what's its purpose? That's a key part, because for you, it's supplementing what you do. You, as journalists, you focus a lot on the writing, the storytelling, but then you have pictures, you have graphics that start to supplement that. When I was in the school newspaper in high school, graphics weren't really existent. It was the story, and our exciting thing was when we could get a picture and we talk our advisor into making a color. We would get a color picture on like 2 pages in the whole newspaper, and that was all we got. Everything else was black and white, no graphics. So now everything's going to the graphics, and it's really exciting because it adds a lot of dimension to the stories and what you're telling. So talking about how do we make those graphics correct and what are the components is an important aspect of that. So that's what I want to talk about today. So you want to flip it. I'll be surprised at what's on the next slide too sometimes. But this I got from a website because it was 2 years ago. I do not remember where it was, but I thought if I'm going to talk about the purpose of it, I should probably Google purpose of a graphical display. And this is kind of the stuff that they included. And there's some really good stuff here, showing data in an unbiased way. What does the information really tell us? That's our goal, is to tell the story and tell the correct story, the accurate story. So we want it to be unbiased. Now, we know that you give 2 people the same set of data, could they come to different conclusions? Absolutely. So it's not that the set of data always says the same thing. It depends on your perspective, but we want to present it in a way that's accurate with what it's telling us. So there's a great example on a Planned Parenthood graph that I'll show you later where, depending on what the story is they wanted to tell, it told a different story. So we want to be unbiased in that, okay? But you can kind of read through here. There are some things that I already know you're doing. Encourage the eye to compare different pieces of data, make large data sets coherent, present the numbers, because lots of data, you don't just publish all the data and say, you figure it out. You want a graphic that tells the reader what's there. And so presenting it in a small space. You can ask 1,000 people something, and then one little graphic this big on your page summarizes all that. So that's kind of the purpose as well. All right, next page. So here's just an example. I thought when I did this 2 years ago, the thing that was exciting was the election. Everybody was excited about it. I think I did this in November, so it just had occurred. So I had a list of data, maybe something that we gathered information, we sampled, we had gender, age, race, state, who you chose for president. And there was a lot of discussion about who was voting for Trump, who was voting for Clinton, who was voting for the other people. I guess they have names, but they're not as important. So, but how do we determine which of these variables is associated with that choice? This is important to the candidates. Who are they going to go out and try to get votes from? It was important to the people who are trying to understand how the voting occurs. So if I publish this, no one's going to enjoy it. They're not going to come to the conclusion. You want to summarize it. So let's say we're only interested in how do the different genders choose the president, who they're going to vote for. So the next slide. This is a graph that does that. It's not a pretty graph. I just got something free off the internet when I made it. But I think some of you will recognize something like this in the highlight in the last issue. So we have the males and females. We broke it down by who they voted for. It's pretty clear that females tend to vote for who more than males. Clinton. And the males tend to vote for Trump more than females. It's not an exciting graph. I look through the highlight every time, and I see graphs in here, and your graphics blow me away. They are unbelievable what you come up with. And I'll just ask right now, how long does it take to make a cover like this? How many hours do you spend to generate this?
On this one? What, overnight?
Oh.
Because it wasn't just the cover, it was then, in the inside too, a different picture of it. Yeah, then it was like the same idea, but a whole different, your graphics are awesome. So I know that you would create something more pretty, more appealing to the eye. I just wanted to get the idea that take lots of information, one quick graphic. It summarizes it quickly. Okay? And it's all factual. You may believe it tells a different story than somebody else, but it is factual. When we do graphs, one thing we always like, percentages. A lot better to use percentages than to say 100 million males voted for Trump. Well, what is that as a percentage? So that's kind of, always keep in mind, let's look at percentages. Okay, next one. So here's what I had, some of the features: provide information, show a trend, encourage comparison, examine relationships. If it doesn't do one of those things, it's probably not going to be beneficial. So as you're kind of flipping through and saying, okay, I got a graphic here. Does it do one of these things? If not, you're just trying to put something pretty on the page. And it's great to be pretty, but we want it to have, purpose to it as well. So always think about that as you're kind of coming up with this stuff, okay? If it's just to read numbers, then maybe a table would be better. Sometimes we can say, hey, it's 40% versus 60. And you've got a whole graphic that shows that, but I get to say 40% versus 60, and that summarizes it pretty quickly. So it doesn't always have to be a picture or a graph. It can just be given the information. But if there's a lot of information, then a graph does better. All right, so here are some from 2 years ago. I was going to update all these with things from the volume 83, number 2 issue. But then I fell asleep, as I told you. And then I couldn't figure out how to get all the graphs in a nice spot, which Carson showed me where the link is on your highlight website. So I just thought, it's also good because these people are gone. No one's going to feel like, oh my gosh, it's my graph. No, this is not going to go up. But Brian, yours did make it. It is there, Brian. All right, so let's talk about some things. Which graphs do you like here? Which things, without the picture, wouldn't relay good information? How about the top? Does the graphic actually provide meaningful summary of statistics that couldn't be done in a different way? I kind of feel like the picture's there, but I'm just looking at the numbers anyway, right? The picture really isn't doing anything for me. It's pretty, it's nice, I like all the circles. It's appealing to the eye. This one, I feel like, kind of does do some comparison, right? I can kind of see how these differ. But there's one issue with that where it's kind of, rubs me the wrong way. What is it? Yeah, they have different radius, or radii. So as I look at this, I know it's 50%, but it looks like about the same, do we want to use a math term? Arc length? No. Don't want to bring math into it. But it does, as I start comparing, it is hard because you're talking about percentages, but yet the actual distance around the circle in terms of its, the roll is the same, pretty much. So it's hard to compare with all these concentric circles. Okay, so that was something that kind of got me. This one I really like. This is a good one. It gives me a quick visual. It's 26 million. I can kind of see that. Here we're 1 out of the 5 jobs. So some of them I think are good, some are not, but I feel like sometimes we're just making graphics just to fill the space. And maybe that's the purpose. I don't know. I don't think it is, but kind of. All right, let's look at the next one.
I use the term to illustrate, not decorate.
Oh, well, I like that, yeah. We want to illustrate, not decorate. This one, I think, does both. I can quickly see a comparison of 1 out of 3 women versus 1 out of 7 men. I like that guy. I think that illustrates. Okay, so this I thought was good. I don't know about 14 to 16%. I'm not sure if that's the right ratio of the gavel there. but this I could compare pretty easily. Oh, hold on. Let's see. Yeah, percentages here. I thought those were good. Comparing, the 2 different groups. I can see it's the same size circle. A good comparison there. Let's look at the next one here. This one has something I really like on this graph. Look how they started at 0. That's actually a good way to do it. And we have some bad examples from Fox News that you'll see. I think it was Fox News, where they didn't start at 0, and you'll see how that's an issue. But this is a great one here. I thought that was good. These comparisons I thought worked well. They're different images, but it did show some comparisons. The decorate the bag. Does the green and the red look about the same area visually? It almost looks like 50% balanced to me, but I think what happened is they went a certain distance up, but the bag then got what at the top? It got narrower, so I would have said, oh, it's about equal, 50-50. And I say 40, well, maybe it's not equal. All right, so the next one. Okay, here we go, Planned Parenthood. Okay. This is a graph that was actually, Americans United for Life, they have no interest in what you think about this, I'm sure. They're not trying to persuade you anyway, but here abortions go up at the cost of what? Cancer. It's clear. I mean, how could you argue with the graph? Right there. All the facts, and they, look, if they were trying to lie, they wouldn't have put the numbers in. So clearly it's correct. We got an X scale, no Y scale. Let's look at the next one. Here it is with the correct Y scale. We got our Y-axis now counting the right way. See, you can see exactly what we just said, right? The abortions are increasing at the cost of cancer screenings? No.
Did you make this graph?
No, I found this actually elsewhere. This is a very popular, as soon as,
Yeah.
yeah, statisticians, they see a graph, they get into it quick. It doesn't take long. There's one I did modify that you'll see later, I did for class. Okay, but yeah, this tells a different story. Same data, different story. Now, which graph is unbiased? Jeff? Let's go back and look. This is definitely unbiased. And we actually have the other things they're doing. So you can see there's a lot more going on. They're spending money on contraception. Am I allowed to talk about that here? STIs and STDs, what does the I stand for? There were only STDs when I was a kid. That sounds actually me. STIs, sexually transmitted infections? Okay. Yeah. I don't know the difference between infection and disease, but yeah, there's a lot more going on. So when you start looking at everything else, you can see they were not increasing abortions at the cost of cancer screenings. It looks to me like what? It just went down. It had nothing to do with this. When you start comparing that it went from like 290,000 to 300, and that dropped about 2 million down to below 1 million, it was not because they spent money elsewhere. They probably just got funding cut.
Is that what we would call the difference between a causal and a
Correlation versus cause? No.
Can you look at that and say that one causes the other, or they just happen to just correlate?
They could just be an association there that happened by chance. There could be other things. Yeah, there's no way to say if we go back to the previous graph, Carson. It's just because you see the relationship that, hey, that went down, this went up, it must be a causation. That's not even true at all. So it really, to get that causation, it has to be a manipulation of stuff. Right? We change something and see a change in the other one. Okay, let's go one more over. Here's a different way to look at it. I told you I like percentages. Maybe percentage is not the easiest to look at here. But this is actually same data showing percent change. So after 1 year, the abortion procedures went up about 5% and cancer screenings went down 5%. Now what would most people assume? That's 5% represents the same thing, right? But if you go back to the previous graph, it went down 5% from here versus going up 5%. It's a whole different raw amount that's changing. So we have to be very, just think about what are the numbers we're showing and what do they actually tell. So if you go to the next one again. There we go. So this is hard for people to see, but really you can see that abortion procedures have increased. They barely went down, increased a little bit, went down again, increased, or then stayed about the same. Where it was the cancer screenings that kept going down almost regardless of what happened here. But you do see they both kind of had an uphill thing. But now we get into a question. Did it go up from 2007 to 2009 or did it go down? It actually went down. You have to think about this graph. A lot of people see the upward part and they're like, oh, it increased from there. Did it really? No, in 2009 it decreased how much? Like negative 4%. It did not decrease as much, but it did decrease. So if you want to really stress yourself out, you've been calculus. That's like talking about the derivative, isn't it? And the second derivative, yeah, it's all that. Right. Who do you have for calculus? Oh, this is going online. We cannot say. I won't make you say Beck or calculus. All. Right back. All right, next one. Was that right? She nodded no. No. Here's a good one. So this, I have so much issue with anything education. I very rarely find good graphs, but this is source U.S. Department of Education, National Center for Educational Statistics. Believable now. In 2007, 5 books represented 75%. I got my Inspire out and divide, that's 15% per book. Check it out in 2013. 15, 30, 60, 90, 120% of graduating. Okay? This doesn't give a fair comparison because they didn't start at low value. Didn't start, remember the graphic I showed you earlier in the holiday one? Started at 0, that was an excellent, this did not start at 0. So the comparison is obviously they're trying to show something that's not there. A 7% increase is not as significant as what it appears in the graph. It's a misleading graph. We don't like that one. All right, next one. Here we go. Yes. You know what? I had some from Obama. I don't want people to think I'm attacking Democrats. So Fox News, they did the same issue. Look at the Bush tax cuts. It's a huge increase. I mean, I was supposed to say huge. I'm not sure now. Look, they started at 34. Where is the rest of the graph? It's not that big compared to what it was, but it appears to be that way. So that's a bad one. Fox News messes up too. Not just once, they'll mess up again. You'll see. I'll let you read this and we'll see what you think. I know what my wife said, our kids are not playing sports. 5.2% of kids get spinal injuries? That's what people see. For which children are hospitalized? Oh, that's a different group, isn't it? So and they told it here. It's there, but I mean, common injuries children suffer. Do most people read this? Probably not, but that's a big important part. 5.2% of all kids don't get spinal injuries. It's of those who are hospitalized. I looked it up. Here's the actual rate. Just a tad bit lower. Okay? Just a little bit. About 5.2% lower. That's it. So that's a tough one. You want to make sure, I mean, how do you relay accurately? And this is not for me to say because I'm not the journalist here. It's your job. If you really want to show that it's among people hospitalized, how do you make your graphic illustrate that so when people see it, they're thinking about what it really represents and not something else? And my wife did decide the kids could play sports, so. Here's one. I don't need to say anything, I don't think. I told you Fox News comes up twice, maybe 3 times. Yeah, that is bad. It should add up to what? Just make sure we're clear.
193.
That's what it should add up to. That's what percentage is always out of 193rds. This one was actually, this I did myself. So this showed up. I don't know. I haven't watched the State of the Union address since then. But I was watching this one. They had Obama. Every time he said something, they had a graphic, because the graphics are where it's all at now. And this was the graphic they had. They had actually the correct answer, the GDP for the U.S. there. Because people don't want to look at numbers, they want to look at pictures. That's why we have graphics. It relays the information without having to stress people out and cause post-traumatic stress disorder from math class in high school. So we have the picture. Now, if I asked you to guess what this was, because remember, people are looking at the pictures, they're not looking at the numbers. When this slide goes away, they were not thinking, oh, it was this versus this. They're thinking China fit into the U.S. like 5 or 6 times. That's how many more times the U.S. GDP is in China. Now, this I didn't like. Let's look at the next one. This is the one I created. It took a little while, but it got me out of grading. So if I have something I can think of, oh, this is important, I cannot grade because it's important that I do that. So this is the graph I would think accurately displays the relationship. What would you guess here? 15? Those of you in stats have seen this graph. We talked about in class, so you know the answer. Who said 15? Not in stats, right? Maybe you are, I don't know. Not in my stats class. Maybe you have steel. So here's what I did one year. I actually went out, I gave both graphics to my class. It was, I think I had a calc survey class. They had not done anything stats related. I showed them the graph of the circles. I made them all guess. On both slip of paper, they handed it to me. Then I showed them this. I said, guess. Now remember, the goal of a graphical display is to relay accurate information. We want people to see the correct relationship. So I summarized what they had. Do the next one. So here were the estimates I got from intelligent kids. These are kids from Carmel High School and Calc Survey. They all survived regular pre-calc. That tells you their intelligence, all right? Here were their circle graph estimates. Here was their bar graph estimates. Which graphic did a better job of accurately relaying the information in a consistent manner? Definitely the bar graph. The circle graph, people didn't know how to, they make their own decision how to compare. You can't control that. So you have to display it in a way that you know they're going to do it the right way. The circle graph, some people did right. There were some who said, yeah, they're probably talking about the radius, not the area. But visually, what do we see? You see the area. That's what we're left with. So the bar graph does a better job of that. So that's kind of what you want to do when you're making graphs, is it relaying the information. Okay. Asim. Where's Asim's sister? She's still here. Is she not in the highlight this year? No. So this is the graph that we have here that Asim made, and I stumbled across in the highlight the day Asim was in class. I put it up, I'm like, Asim, and he's like, uh-oh. He didn't actually say a single word, if you know.
Yeah.
But he thought a lot. Look, 11% to 14. How much bigger does this group look than that? A lot more than 14. Remember, people aren't going to remember what? Not going to remember numbers. They're going to remember relationships between the pictures. That, wow, from 3 to 6 p.m., twice as much. That's all they're going to see. So Asim went back. It's like midnight. I get an email from him. And this is the new email. Now, he agreed that it showed the information accurately, but he goes, I don't think this is visually appealing. And I agree with that too. I think that one looks cooler. But they're both pretty cool. They're both far better than what I would have created. This one does a better job of relaying the accurate comparison, 9 to 11 to 14. You can see it's changing, but it's not changing as significant as this makes it look like. So sometimes we do these graphs. What are you laughing at, Brian? Sometimes we do these graphs and we get the artistic part, but we forget that we're trying to relay information. So keep that in mind always. When you're done, does it accurately relay the information? All right, let's look at the next one. Volume 83, number 2, Brian Zhang. Fantastic. Hey, this I liked. I really did like it. And Brian, I think I made my first comment on the highlight. Who gets the highlight.org comments people make? I posted a comment. Did you see it? You approved the comment?
It's on it.
Oh, it actually shows up for oh, I thought I was just commenting to Brian. I did not know that. I can published.
You're part of the.
I don't even remember what I put. Here's my favorite part of this, was check out how we conducted our survey. Now we're starting, so everything's moved over time from all we had were stories and pictures. Now we got graphics in there. Now we're starting to not just create graphics, but we're actually collecting the data that are our graphics. So now that introduces a new element of how do we get the right information, then make the right graphic for it. And Brian, something I'll follow up online with. Like, how did they get the data? So this was fantastic. I was very impressed with the fact that they did that. I liked it. I thought that was a good thing. So kudos to that. Now let's go back to the graphic. Started at 0. Good comparison. Liked it. Here we're looking at two numbers. People aren't going to remember the numbers, remember the graphics. It started at 0, there's no like scale, but you could measure and see it's pretty much started at 0. I like to get out my ruler and check some of those. And so I thought that was good. Here was a good comparison. You actually can quickly see from one group to the next how the percent of yeses and nos change. Great comparison. So I thought all the graphics in here were good. I liked them all. And the follow-up with that I liked even better. All right, how about the next one?
Can I ask you a question?
Yeah. You want to go back to the last one?
Because the percentages on the left of the fact that we only interviewed, I think it was 14 or 15 freshmen compared to.
Yeah.
Now, of course, freshmen wouldn't necessarily have the feedback provided by Combos because they didn't go last year, but what are the percentages that we need to make a survey statistically relevant and accurate?
It really should not be like you have to sample 10% of all the kids. It's really the amount you sample. If you sample 100 kids from from Carmel High School and 100 kids from Tipton High School, that sample of 100 is going to be just as effective.
Would it matter if you, you have to make sure that you're trying to get males and females and a nice ratio of different grade levels?
If it matters, if you want to say that, if you think that males and females are going to respond differently, which we saw with who they vote for. So if I want to know we're going to predict the election, who's going to win it. If I ask people and I get way more males, I'm going to overrepresent that group. I'm going to end up with a biased answer. If I think gender matters, then I want to make sure I get a good balance. If 60% of Indiana's male, then I want how many of my sample to be male.
That's interesting. Like Gallup says, I think we'll go with Gallup, they say 7%.
7% of the population is what you
try to get. You try to get statistically.
Yeah, the more you sample, the better it is. If I sample 1,000 kids at Tipton High School, do I know more about Tipton High School than I would about Carmel at 1,000? Yeah, I know everything about Tipton now, plus more. And extra kids. Here I only know 20% of the information. But, so it does affect it some, but it shouldn't be a percentage. It's more the raw frequency, like how many are you sampling? Sampling 100 is more important than saying sample 7%. So there's no right or wrong there, it depends on the situation more than anything else.
But likewise, there's too few a number, I think, but you only.
Yeah, you're not.
5 kids, 10
Well,
kids.
that's never going to tell you anything, unless your population's 5. Then again, you're in good shape there. But if you look at, you go back to that graphic. So you mentioned something that was great, and I remember reading this. I forgot about it. They don't put freshmen in here, and I think you included that on the other page, right? That you explained we didn't have very many freshmen, and I think did you mention also why you excluded them? So you didn't have very many, but they also didn't have the perspective to say, I've never been to a combo, I don't know if I would miss it or not. So in a few years, no one will have been to combos, and then it'll be no one will even care anymore. Okay. We won't sample anybody. All right, next one. So this was, I think, page 2. I don't know who did this one.
No,
Howdy did this one? Share responsibility.
What axis do you think I looked at first?
Okay.
Yeah, so this I like. But then I looked at which axis. Here's a distance of 7. And then it went up 19, then 17, then 15, and then 16. Alright? So the x-axis, and I understand why. I mean, you have the graphic, you split them into groups, and the generations are just kind of the way they are. So I don't know if necessarily I'd say this is a issue, because it does show, kind of the picture you want, but somebody could criticize that and say, hey, you're not consistent on that. I don't think, is this really the right graph, or did you just make something that visually looks neat? I don't know. Is it real data that goes with this?
I would hope so. Well, because if you do the 7 years, like you're saying, so that would squish that first one even closer, that would make that rise even more steep.
Yeah, it would.
At the beginning.
Which almost, if you look, the very beginning of this is when in the next generation was very steep. So maybe it does fit more with that part of it.
They point to a post-World War II baby boom.
Yeah. And there's numbers in there that kind of support some of it, but that was something I saw. I just started flipping through and looking at the graphics and thought, why not just talk about each one and the good and the bad. I thought this was great, and I will say though that sometimes we're comparing it. It actually. So these are birth rates. Yeah, so that's okay. That makes sense. All right, we ran out. So can you go to? I'll tell you. I just went through and posted each of these. Someone got worried. I said the orange were the good and the blue were the bad. Just make sure. All right, next one I had was page 10. Standardized spread. Remember the one I talked about earlier? I told you you'd recognize. That's essentially the same graph I had, wasn't it? And look how easy it is to compare the different groups. You can quickly do that and summarize information great. It was based on percentages. There was no label down here, but the label's in there. I thought that was good. Who do we give credit to here? Oh, Samina I have in class. I don't think I have the others doing. Where's Samina? Now, let's do the next one. Page 14. I don't really have anything to say on this one. On here, we had the comparison, so I liked how they kind of looked at it based on a total. So Carmel High School, well, we're out of, what's it, 5,300, what are we at, 50? We always have the exact information. Compared to 6,000, where's the 6,000 coming from? Really, that's not, like, I think what you wanted to do was compare University to Carmel, right?
Yeah.
But you compared them both to 6,000. What if we chose like 6 billion? Like, how do we choose 6,000? Kind of arbitrary choice here. The graduation rate, both compared to 100. That works out well. The SAT score, both are out of 1,600. So I thought those were good in the comparison. I can quickly say, real quickly, I can look and say, they both have similar SAT scores and similar graduation rates. I mean, 100 versus 98, we understand why it's different, right? They pick who they want, and they don't like them anymore, they send them away. Like, you're not going to graduate, we can get rid of you. You're no longer, we can't do that here. So, but this I thought was strange to compare, to pick 6,000 as an arbitrary choice. All right, next page we had page 37. Almost like I'm really reading it in person. Do we like this? Who do we have here? Was this Grace and Emily? How come some of them say who the graphic is attributed to? Does it only tell if it's different than the people in the story?
It's under the title of the story.
On this one it is. Usually they should put it on the graph.
Oh, photos and graphics. Okay. Yeah, there it is. I missed that. You think I like or don't like this one? Well, as a colorblind person, but I can match up the shades at least. No, I like this. Did you start at 0? Yeah. I also like that it said median. It didn't just say salary. Like, oh, well, I will make 44,000. This is the median. There's obviously variation. Some make more, some make less. It identified. I thought that was good. So it gave the comparison, and it didn't have to be like an X-Y axis labels. I mean, you don't have to label if you're doing it right. You're relaying the information. So I thought that was good. It looked to me like 31,000 versus 64. That's about twice as big, isn't it? All right, next page. We have 49. Jessica's page. Again, started at 0. I liked that. I thought that was great. I thought the comparison of the two different amounts of people, I can do a quick comparison without ever having to see the number. Hey, it was 53. So I thought this was good. We got Angela on this one. That was nice with Angela. There you are. Good job. And the last one, I think it's Misha's. Is Misha here right now?
No.
Let's zoom in on this. Misha's not here, so I can't ask the question. Oh, Michelle did this? It was Misha's page. Michelle here? Right away. All right, Michelle, I got a question for you. Did you copy and paste? Or are these different images? Did you click and drag? With like the shift button, right? Now what does that do? And I'm not criticizing or saying it's good, I don't know yet, but did you increase the vertical amount to make it about 6 times bigger, or did you just increase this visual area? What would we want to do? Well, what are people going to see? They're going to see the area. So we definitely know she didn't just pull it vertically, right? Because 6 times more would be a lot more. So if we're increasing the area to represent that ratio, which I don't know if you did or didn't, I'm not saying one way or another, but then it's perfectly fine. So I liked here where it looks more like you did an area visual than a height visual. Like, we don't want to stretch it just vertically, because now it's all distorted and doesn't look right. So I like how you did that part and you made that fit more than you did just like, making it 6 times taller. So nothing to worry about here. You get nervous I was gonna say something bad. Yeah. All right, so hey, look, overall, as I read it, I'm always impressed. Yeah, I'm gonna find things wrong, but who's sat in my class and taking a test or quiz from me? How's my grammar? Not the best always, right? I got some things I can learn, and people are more than happy to tell me that. I'll give the quiz, I'll go to grade, I'm like, they marked up every grammatical error I've made. I don't get offended. I'm like, oh good, I can fix it, thank you. So the goal here is not to criticize, the goal is to, let you know you're doing great things, I love what I see, but we want to just try to keep in the back of our mind, we're not just trying to, what was the saying you have, Streisel?
To illustrate, not decorate.
Yeah, the goal is to illustrate the information in an unbiased way, that people are going to see the information that's there without having to look at all the numbers.
Well, I heard a couple of great takeaways. One was you said always use percentages, because percentages are more representative.
Yeah. Well, I usually like, there was that one though where it made it tough to, but yeah, percentages I like.
And I also heard starting at 0.
Yeah, that's a big
What
one.
other takeaways should they take from, as they're looking at data and thinking about how to present that visually? What other things would you think? I know back in the past you talked about timelines, never cut out the middle.
Oh yeah, that was one we had one time. Yeah, a lot of people will cut out that middle part and then it'll jump real quickly. So I think just showing all of it. I think the area principle one with Michelle's, I thought was great to think about what people are going to see and without the numbers.
The other thing you said was talking about tables versus spending the time to put together a graph. And I've said this before too, like it takes a while to do a graphic. So if you just have 2 or 3 numbers, like why are we putting it in a graphic? Why can't we just stick it in the story or just do a quick fact box and put it in there, as opposed to taking the time to do some of this, which you are saying basically is taking large bodies of information and sort of consolidating it to something that's easily read by others.
Yeah, I think doing the tables or just the numbers are just as good, just as effective, and that may open up room for other creative things, pictures and other graphics you can do instead of just a circle of 2 numbers, 20 versus 80% type deal. Anybody have any questions or anything I could?
Guys, we're going to put this presentation up on the reference page on Highlight, and then Emily was videotaping it, so we'll put the presentation for those who didn't see it today as well, because I know it's SRT and not everyone can come. So Mr. Wernke, thank you so much.
Thank you for having me, I appreciate it.
I have a question.
Yes.
So, sometimes I think people have trouble writing questions that, in a survey that will give accurate data.
Yeah.
Do you have any tips about that?
You want to make sure when you ask a question, you get, it's not that you want them to answer a certain way, but you want answers that you can compile. So if I ask, how often do you do your homework? This is the example I gave in class. Some will be like, all the time. Some like most of the time. Some like 40%. Some will say 3 assignments a week. Some will say I do homework 2 days a week. So just asking questions that give us those consistent results that, how often do you do your homework as a percentage of all the assignments you've been given this year? Because if one kid says I do homework in 4 classes, and they're TCP, that means they do what? They do all their homework. You ask a junior says I do 4 of my classes homework, and they're only doing 4 out of 7. It's a whole different comparison. So I think when you write a survey question, there's no way of saying here's the right way to do it. But anytime you write a question, give it to friends. 5 or 6 people, say, hey, read this and tell me how you would answer this. And as soon as you start hearing their way of answering it, you're like, ooh, that's not what I meant. I got to rephrase that, or I got to specify more. Answer as a percentage, answer as number of classes. If I ask another teacher at another school, how many tardies do you have? And they say 50. How about you guys? I'm like 300. Like, whoa, you got a tardy problem. No, it's 300 out of 5,000. We're actually pretty good. We got about 6% of our schools tardy. That's it. And he's like, oh well, for us it's 20%. That 30 kids, we're real small. So just thinking about how someone would answer that is probably the most important thing, and you're only going to know, because we do these surveys and we ask questions, we read it the way we read it. And same with my tests and quizzes. The last quiz I gave, I typed up a question. In my mind, I knew how I wanted it read, but that's not how it was read, was it? You remember the question?
No.
Yeah, but that's not how I phrased it. And then someone came up and asked me a question, like, what do you mean by this? I could pick one, like, oh, that's not what I meant. But until someone else read it, and it was my fault because I wrote that quiz question like at 2 a.m. Showed up at school at 7:40, copied it, and handed it out at 7:50. I didn't run it by anybody. So that's probably the most important thing, is you actually test your questions and make sure that people are reading the way you want. Yeah.
Well, thanks
All right.
again, Mr. Wernke.
Thank you. Keep up the good work, everybody. I enjoy it.
The more adults we have in the room, the better we are all.
I got a little nervous. No one asked me to come down last year. Oh, I didn't know it.
Well, it was still fresh.